Hi, my name is Owen and big ideas like physics, neuroscience, and philosophy make me lose track of time. These big ideas are so interesting to me because I love learning about the world around me to the fullest extent I can. The most recent topic of my fascination has been something called chaos theory. I first discovered it, as I often do, during a YouTube rabbit hole. I watched one intriguing video, that made me read a book, that made me watch even more videos, and so on. You know how it is. But this series of events informed me about something called the bifurcation diagram. Let me show you what that is. First, we have to create an equation that represents a population of animals. X. Say these are porcupines. X is the population of porcupines. R can be the growth rate of porcupines. If R is 2, then the population of porcupines will double exponentially. That's too many prickly pals. I think we need to add a constraint. 1 minus x. X now serves as a percentage of the theoretical maximum of porcupines, 1, aka 100%. Now we have a constraint which serves as a predator in this natural situation that decreases the number of porcupines. This equation is also now a negative feedback loop. And if x is the population this year, then by using the rate of change, we can determine that this is the population next year.
Here is a graphical simulation of this equation, where the left side is the population over time. The population is on the y-axis, and the time is on the x-axis. After a few units of time, the population reaches a continuing equilibrium. On the right side, you can see the equilibrium as the growth rate increases. Equilibrium on the y-axis, the growth rate on the x-axis. You can see that once r reaches 1, the equilibrium increases steadily with the growth rate. But once r reaches 3, the equilibrium splits into 2 oscillating bifurcations. In other words, the population goes through 2 different totals before repeating. 1, 2, 1, 2, 1, 2. Then, when the growth rate reaches 3.5, it splits again, and the population now goes through 4 totals before repeating. These doubling bifurcations continue until it devolves into complete chaos. The interesting part is, though, even though the chaos has no pattern in the population, it is still predicted. Therefore, we have predicted randomness.
This is just simulated randomness, like pi. But what makes it really interesting is that any other equation with this same negative feedback loop will graph the same exact diagram. That's so interesting because it applies to so many different areas of science, and it applies to randomness that we see in everyday life. A few examples are air turbulence, liquid convection, dripping water, and even induced fibrillation. This was only scratching the surface of one of the things I learned in my YouTube rabbit holes. I love these big ideas because it's so amazing the way people find intricate ways to link natural phenomena back to its original cause. There's really no end to the learning, and it's just amazing.